Okay, so we're going to look at angles of depression and elevation. Really simple. Basically, your angle of elevation. So let's say you're standing here by this house, okay, out towards the horizon, or think of that as being the ground, is 1. And then when you look up to the cliff, this is your line of sight. So basically the angle in between there, this is your angle of elevation right here. Okay, so let's look. Example 1, a pilot is flying at 10,000 feet and wants to take the plane up to 20,000 feet over the next 50 miles. What should his angle of elevation be to the nearest tenth? Well, the fact that he's starting at 10,000 feet is kind of irrelevant. If we look at the difference here, so from 10,000 to 20,000 feet, that is a vertical distance of 10,000 feet. So we're kind of picturing this. Here's the plane. Okay, so we're going to increase. So imagine, like here, if the plane is flying at 10,000 feet and they want to get to 20,000, then that's a difference. So what we end up with here, and this is going to be over the next 50 miles, we want to figure out the angle of elevation. So first of all, we're talking about this angle. I'm going to use the Greek letter theta. It's just, theta is one of those letters that's often used, or most commonly used, as to represent angle measures. Okay, so the way we're going to solve this is using trigonometry, or SOHCAHTOA, and we want to look at, well, first of all, we have this here would be our opposite side, and this would be our adjacent. So I know I'm going to use, if we picture SOHCAHTOA, we want to use tangent, right? Because we have opposite and adjacent. The only issue is that this is feet and this is miles. So since we're going to have to switch one of them. There's 5,280 feet in 1 mile. So if there are 50 miles, then we're going to take 50 times 5,280, and we get 264,000 feet. So I can kind of picture this as here, 264,000. Okay, so we already established it's going to be tangent. So tangent of theta is equal to opposite over adjacent. If you want to simplify that, you can. I honestly wouldn't bother. So I have tangent inverse. So if you recall from our previous lessons, whenever you're looking for an angle measure, that's when we're going to be doing the tangent inverse or the sine inverse and so on. So I have, make sure your calculator's in degree mode. So we have tangent inverse of 10,000 divided by 264. And we get about 2.2. Angle of depression. Okay, so this is kind of the opposite of angle of elevation. The angle between the line of sight when an observer looks downward and the horizontal. Okay, so that means your angle of depression here actually is congruent to the angle of elevation, because if you picture that these two are parallel lines, then your angle of depression is equal to the angle of elevation. Okay. So let's look at the next example. The tailgate of a moving van is 3.5, so here's 3.5 feet above the ground. A loading ramp is attached to the rear of the van at an incline of 10 degrees. What is the length of the ramp? So we're looking at this ramp, so I'll call that X. Now, since this is 10 degrees, this is also 10 degrees. So picture here we have a kind of a skinny right triangle. And in relation to this 10 degrees, this would be opposite, and this would be the hypotenuse. So when we're looking at SOHCAHTOA, opposite and hypotenuse is sine. So I have sine of 10 degrees equals opposite 3.5. Oops, that's going to be over x. Okay, now this is a little different than some of the other ones we've solved. Basically what we need to do is we need to multiply both sides by x, so we'll have x times sine of 10 degrees. And then we have to divide both sides by sine of 10. So I have x equals, so I have 3.5, and I'm going to divide by sine of 10, and we get about 20.2. So it's going to be 20.2 feet. Okay, we're actually going to move on to the log sines next lesson, since that last one was really short. So the one thing you need to take away from the log sines is that you do not need a right triangle. Okay, all the things that we've learned up to this point, special triangles, Pythagorean theorem, the trigonometry, with sine, cosine, tangent, with the SOHCAHTOA, you need a right triangle. But here, basically, you just need to know an angle over the side opposite the angle. Okay, now let me show you first. Okay, here's the log sines. Okay, the log sines basically says that the sine of an angle over the side opposite is going to be proportional to the sine of another angle and the side opposite to it. So basically, you could take any two of these ratios, set them equal to each other, and you just have yourself a proportion. So what I'd like to do is actually prove the law of sines. So take any triangle, ABC, and draw the altitude. So our altitude happens to be h. So if I just look at sine of A, so if I'm looking at sine of A, I'm just looking at this right triangle. So sine represents opposite over hypotenuse. That's going to be h over b. Now, let's look at the other triangle. In other words, when I look at this. So sine of b is going to be h over a. Okay, so by looking at these, basically what I want to do is I want to solve for h in both here and here. Well, how do I do that? Well, basically multiply both sides by b here. So I have b times sine of a is equal to h. And here, a times sine of b is equal to h. So now that we have h isolated in each of these, I'm going to set these other two parts equal to each other. And now this is the trick that probably wouldn't have come up with, but basically we're going to divide both sides by AB. So what happens here is the b's cancel. So I have sine of A over little a, and here the a's cancel, and I get sine of b over b. Okay, just a quick note, sometimes there are occasionally situations in which the law of sines does not work, but we will save that discussion until you encounter it in Algebra 2. Okay, so whenever you see the word solve, solve means to find all missing angles and sides. Usually that means there's going to be 3 missing pieces. Okay, so if I look at this picture, there's basically I have 3 angles, R, P, and E. Now, before I start anything, I'm actually going to label. So, for example, here's capital letter E, so I'm going to use lowercase e to name the opposite side. Here's capital P, so this is lowercase p. And then capital R is here, lowercase r. So really, what three pieces am I missing? I'm missing angle R, I'm missing little r, and I'm missing little e. Now the key here is what I need to have. I need to have a side and an angle that are directly opposite in order for this to work. So in this case I have angle P. So I'm going to have sine of angle P, which is 45 degrees, over its opposite side, which is 22. Now, I need to have another angle measure, so I'm going to look at E and its side opposite. So I have sine of 63 over E. From here, no, it doesn't look so simple, but it's basically just cross multiplying. So it's going to be E times the sine of 45 equals 22 times the sine of 63. And then what do I want to do? I want to cancel out that sine of 45 degrees. So I'm going to divide both sides by sine of 45. So basically these cancel. And I have E equals, now be careful when you plug this all in. So I have 22 times the sine of 63. You have to make sure that you close the parentheses, because you want to make sure that you don't accidentally press the divided by button too soon. You want to be able to make sure that that's multiplied, and then you're going to divide by sine of 45, and you get 27.7. Now, angle R is relatively easy because if I have 63 and 45, all three angles add up to 180. So we'll find out that this is 72 by just subtracting the other two from 180. Now, to find out R, it's going to look almost the same as this one that we originally set up. We're still going to use sine of 45 degrees over 22. But this time I'm going to use sine of 72, which is angle R, over little r. Now, some of you may ask, could I have used sine of 63 over 27.7 because we found E? That's fine. It's just I like to play it safe because in case you made a mistake on the first part, you could still get the second part correct if you set it up right. So we're going to cross multiply. Divide both sides by sine of 45 again. And I get, so here, these cancel. So we're going to type in 22 times sine of 72, close parentheses again, divided by sine of 45, and we get 29.6. Next one. Okay, so I don't have a picture here. I'm just going to label it BWY, and then I'm on the opposite, label the opposite sides with lowercase letters. So now I'm going to label what I know. So Y is 66 degrees, W is 59, and side B is 77. So again, we're going to solve. So what are we missing? Okay, so I don't know angle B, I don't know little w, and I don't know little y. Well, angle B is easy to find. Angle B is just going to be 55 degrees because these have to add up to 180. Now remember what I said, you have to have an angle and a side that are directly opposite. So I know sine of 55 over 77 is going to get me started. Now I have a choice, I can find y or I can find w, it doesn't really matter. Let's say I'm going to use w. So I have sine of 59 over w. So I have w times sine of 55 equals 77 times sine of 59. And then w is going to be 77 times sine of 59 over sine of 55. So let's plug that in. 77 sine of 59, close parentheses, divided by sine of 55. And we get 80.6. Oh, that's not degrees, that's just a ruler. Okay, next we're going to find y. So I'm going to use the same sine of 55 over 77. But when I look at y, I'm going to use sine of 66 over y. So y times sine of 55 equals 77 times sine of 66. So y is going to be 77 times sine of 66 over sine of 55. And you can check it, but it's going to be 85.9. Okay, finally, last one. So here's triangle XYZ. So I have lowercase x, y, and z. I know y is 17, and z is 14. And this time, I only know one angle measure, angle y. So I'm actually missing angle x, angle z, and little x. Okay, again, I have a side and an angle opposite each other, so that's what I'm going to use. Sine of 92 over 17. Now, if you look at angle x and side x, these are both unknown. So I'm actually not going to solve for angle x or side x. I'm actually going to look at z. So I know the sine of z. Now z, the angle z, is what I'm missing this time. I know the opposite side. But we're going to go about this just like we did the others. We're going to cross multiply. So I have 17 times the sine of z equals 14 times the sine of 92. Now I can't divide by sine, just like what I'm going to do here is I'm going to divide by 17 on both sides. And I have sine of z equals 14 times sine of 92 over 17. Now I know I'm going to have to do sine inverse at some point, but to make it a little bit easier to deal with, I'm going to take this and turn it into a decimal. So sine of 14 times sine of 92 divided by 17. Make sure you close parentheses. I get 0.8230. Remember, if you're going to use the trig functions on your calculator sheet, always round to 4 decimal places. And then c equals sine inverse of 0.8230. Now, it's nice if you have a graphing calculator, because when you do this, you can just do second and then the negative sign, and that'll take the sign of your previous answer. Or you could just type in 0.8230, but you get 55.4. Now, once you have 55.4 degrees, then you can figure out the other angle measure, which is 32.6, since they all have to add up to 180. And once you know this is 32.6, then you can work with angle x. So I'm going to start it out the same. Sine of 92 over 17 equals sine of 32.6 over little x. So I have x times the sine of 92 equals 17 times sine of 32.6. I'm going to divide both sides by sine of 92. And then I have x is equal to, let's see what we get. So we have 17 sine of 32.6, close parentheses, divided by sine 92, and we get 9.2. Remember, you can't use Pythagorean theorem or anything like that on a problem like this because it's not a right triangle. So only if it was a right triangle could you use that method. And here is your homework.